All right, so today we're starting on the next module, which is SQL, databases and SQL. SQL stands for Structured Query Language. It is the de facto programming language for querying and interacting with a relational database management system. We'll start with database, we'll get right into it today with some basic SQL. But before that, let's go ahead and motivate why we would want a database system to begin with. What you've been working out with up to this point, both in assignment 1 and assignment 2 and going into assignment 3, are what are called flat files. This is where you have a data model with relations between different things, you know, items and invoices, people and stores and stuff like that. But you take all of that data and you flatten it out into one file. For example, here's some enrollment data. Right? So some students here are enrolled in various courses, computer science 2, computer hardware, discrete math, etc. And we've got different students enrolled in different courses. We've got their NUIDs and we've got their emails. So take a look at this data and tell me, what are some anomalies that you see here? What are some shortcomings? What are some bad things about this data? Say again? Yeah, the student name format, right? We've got Tom Waits here, right? Tom space Waits, capitalized. And then there's the same student because they have the same exact NUID right here, but it's then Waits, comma, Tom, all lowercase. Right? So we've got consistency issues. Right? What else do we have? Well, how many people are in 156 right now according to this data? 1, 2, 3, right? And how do you know that they're in that course? This first column right here. The second column as well, right? What do you see though? 1, 2, 3. That same data is repeated over and over and over again. What about that first record right there, that Tom Waits record for the first one?
Empty class.
Empty. Why? Well, because we want this third email here. They've got several different emails. And we want to capture the idea that they have 3 emails, but they're only enrolled in 2 classes. So we'll go ahead and have this dummy record right here with an empty string. Did we represent the same thing down here with that last record? Right? No, now it's none, the string none, or null, missing, right? So we've got a lot of consistency issues here, a lot of redundancy issues. What if I wanted to produce a report? If this were a flat file, a CSV file, if I wanted to produce a report and produce a schedule for Tom Waits, what would I have to do? I would have to go over every single record in the entire file to make sure that I didn't miss one. Right? That means maybe sorting the file, right? And then going back, well, now you want to do it for John Student instead, or you want to do it for a completely different report. You want to compile a roster for 156, right? So there's a lot of issues here, right? Some of which we've identified, some of which we haven't. There is repetition of data. There is formatting issues, right? Is it a last name, first name, right? You shouldn't even be doing that, right? First name, last name, that's 2 different things, probably 2 different columns. We have consistency issues, right? In one instance, certain data was represented in one way, and in another instance, it was represented a different way. This leads to data anomalies. Is that how you spell it? I don't know. Anomalies?
The second is O and
Thank you. I'll trust you on that. It still doesn't like it, but doesn't like any of my spelling, so I don't have a really good spell checker here. Otherwise, we know these as integrity issues. For example, what is to stop me from coming over here and putting hello as an NUID, right? Whereas an NUID is, say, a number, right? There's nothing to stop me from doing that because this is a plain text file. It's a flat file, right? Everything ends up being text. There's no strong typing here at all, right? And so I've got integrity issues. We've got organization problems. It's not sorted, right? It's one big file. Imagine if you had a multi-user application where you have hundreds of people accessing this enrollment system at once, right? And they all rely on one file. What happens to a file when you've got it open? Right? So think about this. You've got a Word document open or something, and then you go and try to take that Word document and put it into the trash. What's going to happen on your system? It's not going to let you do that. Why? Try it sometime, right? You'll come up with this error message that says that that file is in use. That's called a file lock. That when one program is using a file, that locks out all other programs, all other users from using that file, right? Imagine if Google worked like this, and we had billions of people, accessing Google, but only one of them could do it at one at a time, right? That's not going to fly, right? So we've got organization problems. There's no multi-threaded program possible, and lastly, there's no security, right? If you have access to this one file, you have access to everything. Whereas in a relational database management system, the solution to all of these problems, you can actually have fine-grained control. First of all, you can lock somebody out of the database entirely, right, with passwords. Second, you can say, oh, well, I'm going to give you access to that table over there, but not that table over there, because that table doesn't have any sensitive information, but that table does. Right? I'm going to lock you out from making any mistakes by giving you read access only. Right? That's called a view. And so that, I trust you enough that you can pull out data, but I don't trust you enough that you can put in data. Right? So you can have that fine-grained control, but that's only possible if you have an RDBMS. Right? An RDBMS is a relational database management system. Right? MySQL, or SQL, or SQL, or however you want to pronounce it. A little bit of a history here. We'll jump through it as quickly as possible because it's not that interesting. But it is it was established in the 70s, early 70s at IBM by Edgar Cod. The key aspect of this is that data is not stored in files. Ultimately, it's stored in files because in a Unix system, everything is a file. But it is stored, conceptually, it's stored in tables, in separate tables. It looks something like this instead. Right? This is a video game database that we're going to be playing around with here, where we've got publishers, games, platforms, and availabilities. The availability of a game being on a platform. And you can immediately see, that these are separate things. This is very much like object-oriented programming, right? If we've got multiple pieces of data, a game ID, a name, and a publisher ID, should that be screaming out to you? Make a class. As far as a database is concerned, what's that screaming out to you? Make a table. Right? Separate those tables out so that game stuff is in the game table, platform stuff is in the platform table. So a lot of the knowledge that you have from object-oriented programming and good encapsulation is going to port right over to databases. Right? Tables have columns, which are pieces of data, and rows, which we refer to as records. It's kind of like an Excel sheet where you've got columns and rows, but an Excel sheet is just a spreadsheet. It is not a database system. It is not even a database table. Right? But you have the same kind of idea. It's a table. A table has columns, and a table has rows, just like this table over here. Okay? Columns have a type and name, aka we call those fields. So that if I say that there is, for example, over here in this table, there is a name of the game, and it's a varchar 255. So just sound out that word, varchar. What do you think it's short for? Variable character, right? And up to 250 characters are supported in this field. Other things like publish year is an int. What do you think int stands for? An integer, right? And you can have doubles, floats, and a bunch of other things, right? And we won't get into it, but you can have blobs, which are binary large objects, right? But otherwise, those are the same basic primitive types that you have in any programming language. Each row in a table corresponds to a single record, right? And records in different tables are related. This is where we get relational database management system to each other through what are called foreign keys. Right? Records within a table are uniquely identified by primary keys. Again, let's take a look at this table over here. Every table here has this little yellow thing. If you zoomed in on that, it would be a little icon of a key. Right? Those are the primary keys. And you'll note there that I've got a naming convention going on. Game, game ID. Publisher, publisher ID. Platform, platform ID. Very consistent, very well designed. Right? We've got these tables that have relationships between each other, indicated by these arrows right here. This is for a one-to-many relationship. This little crow's, we call that a crow's foot, right? Why? Because it looks like, or crow's foot or chicken foot, I guess it is, right? Because chickens have 3 toes, so it looks like a little crow's foot right here, right? And that is, that relationship there is defined by this little red thing right here, publisher ID. It is a foreign key that refers to a publisher with that particular publisher ID, right? And this forms a one-to-many relationship. There's a one-to-many relationship there, a many-to-one relationship over there. Why? Because a game can appear on multiple platforms, and one platform can have multiple games, right? So it's pretty straightforward here on the model that I'm shooting for, right? Foreign keys define relationships between those tables. A one-to-many relation is one record in table A may be related to many records in table B. Right? And you can have a many-to-one relationship, but it's just the opposite. Many to one, it's the same, but from the perspective of B. Right? So it's just the reverse relationship. What is different from both of these is a many-to-many relation. Right? One record in table A can be related to many records in table B, right? And vice versa. B, there we go. I don't know, many of you are, say, taking discrete math right now, 235. Have you gotten to relations yet? Relations on a set? You eventually will, and why do we call these relational database management systems? It's because pay real close attention to the definition of a relation in your 235 course, in your discrete math course, because this is exactly what it is. A relation on a set or between two sets is a Cartesian product of these things. And that Cartesian product is some subset of the Cartesian product, which turns out to be exactly what a relation is. A relation is a generalization of a function. And a function, you all know what a function is, right? X, Y. X maps to a Y. Can X map to 2 Ys? Nope. That violates the vertical line test, right? A circle is not a function because one X maps to 2 Ys, 2 Y values. But a relation does allow that. A relation is a generalization of a function where you have a mapping from one set to another set, one table to another table. And that's the basis of this database system here. We're going to focus more on the practical stuff. And so we're going to start out with CRUD. Right? CRUD stands for Create, Retrieve, Update, and Destroy. You might eventually see this as if you're doing a web app. It's a basic CRUD app. Right? What does that mean? Well, it means that you're designing a web-based interface so that people can put in data, they can run a report on that data, they can change the data, update it, and then they can delete records, right? It just gives somebody a nice user interface by which they can put stuff into a database for whatever reason, right? Except that they don't know SQL. If they knew SQL, then there would be no need for this kind of interface. Here is where to get started. First of all, you're going to go, like in the Piazza post, you're going to have to get your CSE MySQL account, okay? It's actually a MariaDB account. MariaDB is the free and open source version of MySQL. It's not owned by Oracle. MySQL is owned by Oracle. It's free as in beer. So if you've ever heard that term, free as in beer, like somebody offers you beer for free, it means that there's no cost involved. You don't have to pay for the beer. It's not free as in freedom, right? Postgres, MariaDB, these are free and open source softwares, FOSS, right? And it is free as in freedom because you can take that code, you can modify it, you can sell it, you can do whatever you want with it. Right? And we've got a MariaDB instance on the CSE server, not a MySQL instance, but they're 100% compatible. All right, let's go ahead and log in here. It's going to look a little bit different if you go to cse.unl.edu/account. It's going to look a little bit different here because I'm a faculty, so it's going to have different settings. But if you go to account settings, I already have a MySQL account. you can always come back here and reset your password, okay? Once you've got that done, you should go and download. My suggestion is to use MySQL Workbench. Why? The price is right. It's free, right? If you want to use Eclipse for this, you can. If you want to use a paid product, Aqua Data Studio or VS Code or something like that, you can do that as well. But the price is right here, and so that's what I'm going to use, 0. When you install it and run it, it'll look something like this, except that you have not set up your connection yet. You'll set up your connection by labeling whatever connection you want. You're going to be connecting not to your local host because do not download like the server. You want the client, MySQL Workbench. And then you're going to connect to the CSE server, cse.unl.edu. Do not touch the port. The port is a standard MySQL port, 3306. However, you are not root. I am not root. We should be so lucky to be root because then we can do anything. Instead, you are you and I am me. Right? Whatever your login is, you're going to put that in there. I've already done this. You'll be prompted to enter your password and save it if you want. But otherwise, once you're connected, it'll look something like this. If you are working off campus or if you're working through a VPN, it might be a little bit slower. Why? Because everything being sent to that server and from that server is being sent over the network. I am connecting to this remotely, okay? Now, you can use your database. Let me go ahead and, can I increase the size here? There we go. Your database is named after you, right? So whatever your login, your CSE login, it is not your MySQL, not your MyRed login. It is not your NUID. It is your CSE login, right? The ITS or whoever controls the technology at the much higher level, university level, they're not going to be giving out SQL accounts, right? We give out SQL accounts, but only the one named after you, right? So change this to your login, and then you can use that database. I just executed this by using, now I'm on a Mac, so it's going to be Command Enter. You can click these up here to execute the selected statement, so this one statement here. You can go ahead and execute the entire script if you want to. I'm going to be writing a script here. Right? Use CBERG. Let's go ahead and show what tables I have. Right? I don't have any tables. Right? When you get information back from the server, it's going to be in the form of basically kind of like an Excel file here. Right? And you can manipulate and you can cut and paste this kind of stuff and you can work with this. Once you're done with it, you can go ahead and close it. You can always rerun that query if you want. These are called queries. Right? I'm going to ask the database something. I'm going to query the database for something. Okay? All right, so I don't have any tables yet. Let's get started with this video game database. So through the magic of copy pasta, let me go ahead and come over here. There we go. There's the video game database. And I'm going to execute the entire thing. I don't want to save this, actually. Let's go ahead and execute all of this stuff. We'll get to table creation here eventually. Come on. The entire thing. I want the entire thing. There we go. So that quick key was Shift, Command, and Return on a Mac. I don't know what it's going to be on Windows. Right? You're going to have to come up here and look at this stuff. But otherwise, let me go ahead and get rid of this stuff. Basically, I'm creating a bunch of tables here. And let me go ahead and get rid of it now. And show tables. I created a bunch of tables. I created the availability table, the game table, the platform table, and the publisher table. Right? I have a database that now looks like this. Okay? Let's go ahead and reflect on this database before we get started working with it. I've already said that we've got a game table that represents one single game. Right? And each row in that table represents a different game. It has a unique ID right here, game ID. Right? That is a primary key that cannot be duplicated. Right? What I've done is I've set up the database so that it automatically generates these for me. Because if I didn't do that, I would be doing what's called key management. I would have to go to the table and say, okay, I need a new key. How about 5? Is that already taken? Oh, it is. Okay. How about 6? Is that already taken? Oh, yeah, it is. All right, so some random number, 472. Is that already taken? Yes. All right, keep asking this question over and over and over again. Or let the database do its job and let it automatically generate and do the key management for you. That's what I've done here. Otherwise, we've got a name of the game. Varchar, which we've already intuited that that's going to be a string. a variable character. Right? Publisher ID is an int that refers to the publisher over here. So I've got a one-to-many kind of relationship between the publisher. What have I modeled here? Let's just take a publisher. I don't know, Nintendo, right? So it has one publisher published many games, or is one game published by many publishers? Right? Now, in the real world, you might say, well, both of those are perfectly possible, right? One game can have multiple development houses, multiple publishers. But what I've modeled here is what? One publisher can have many games, but one game only has one publisher. Right? If you want to change this, then great. Go ahead. You're doing a different model. Right? Otherwise, over here in the publisher table, what do I have? The name of the publisher and a primary key indicating the uniqueness of that publisher. What about the platform table? Very, very similar. A primary key that indicates the identity of that platform, and then the name of that platform, which is also a string, varchar 255. So some platforms would include Xbox. What are we on now? Xbox, Xbox 360. What are we on now? Series X? Okay, all right, Series X, all right? And we're now on PlayStation 5? Yep, okay, great. Those are two, or PC, or Mac, or just Steam, or whatever, right? Or the really cool one, the handheld Steam, is what? Steam Deck, right? I'm getting me one of those eventually, right? Anyway, once they become available again, are they back now? They have more? Okay, so maybe I do need to buy it when I get some money. Anyway, what do I have between these two tables here? Game and platform, right? I have two foreign keys because check these out. This is a red. That indicates a relationship back to the game table and a relationship back to the platform table. One game can appear on multiple platforms. One platform hopefully has multiple games. Otherwise, don't buy it. And then we've got a publish year. Why didn't I put the publish year over here in the platform? We could have a game that was published in 2019 on Xbox, Series X or whatever it was, right? But then it took another year. It was a release exclusive or something. And then a year later, it was released on PS5. Right? And so it has a different year, right? If I put it over here in the platform, that means that every game published on that platform would be published in the same year, and we know that that's not true. Right? That doesn't even make sense. We know that if I put publish year over here, then that means that game was published on every platform in the same year, and we know that that's not true either. So I've got it over here. And likewise, I've got a unique identifier for the availability table. Right? That's a very simple four-table model. Okay? Now let's go ahead and start doing some basic CRUD. Create, retrieve, update, and destroy. I will save the best for last, because we need some data in there first, right? We need to be able to insert some data, we need to be able to change some data, and we need to be able to delete some data before we do all this fancy querying out of the database, okay? So let me come over here to, in my mind, I'm always calling it Aqua Data Studio because my last job, which was 10 years ago, that's what they bought us, and that's what they gave us. But I'm not paying the $40 that it costs. So I'm going to go ahead and use MySQL Workbench here. Don't pay for it either, right? All right, so I need to get some data into those tables first of all. Here's a preview of what the data actually looks like. We'll talk about selection and querying out of the database eventually, but for now, let's go ahead and just see what platforms are in there. All right. Oops, there we go. Select star from platform, excuse me. There we go. All right. And unfortunately, I'm not going to be able to zoom in on this. It doesn't work. I can zoom in on the queries up here, but I can't zoom in on the, or can I? Nope, that's an addition, right? Undo. I don't think I can. Darn it. Anyway, we've got Xbox, Xbox 360, PlayStation 1 through 3, Nintendo Entertainment System, NES, Game Boy, and Super NES. So you can pretty much tell where my video game career ended, right? Back on, I don't even think I owned a PS3 actually, but I do own an Xbox 360 still, and it had the red ring of death once, but it still is not. It's still chugging along. So, yay, good job. All right, so select star from, the star, by the way, is a wild card. Select everything. Select everything from game. Let me show you all the games that I've got here. GTA 1 through 4, The Legend of Zelda, all the way down to Out of This World, which is a PC game. Right? All right, so we've got some select star from publisher. There we go. We've got LucasArts down to Delphine Software. Okay? All of those things are 3 different tables, and I won't bother with the availability table here until later. So let's start by, I don't know, inserting some publishers. Right? So let's go ahead and create a new publisher here. And I do like this ancient data because that means that you can give me new publishers to put into this, and I almost have a guarantee that they're not going to be in this database already. So what is the hot game right now? Say what? Among Us. Maybe 2 years ago. Okay, well, that's, which one? Last of Us 2? First one? Okay. All right, well, let's just go with that. Who's the publisher there? Naughty Dog. Naughty Dog? Yeah. Like that, or a space? Let's Naughty Dog like this. All right, so let's insert a new record for the publisher, Naughty Dog. So to insert data, you use the keyword insert. With CRUD, create, retrieve, update, and destroy, we have these keywords here. Insert, select, update, and delete. Only update is the same, right? And so creating data means that you're inserting brand new data. Insert into publisher. And now what I need to do is I need to specify the columns. Let's come back over here to, by the way, this is called an ER diagram. That in a couple of weeks after the spring break, when you turn in your design document draft for your database design, we're expecting something like this, very similar to your UML diagram. Just a sketch initially, but otherwise, this is not a sketch. This was auto-generated after I created the database. That's what goes into your final draft, all right? So you don't have to work at it. All right, so I've got, let's see, publisher over here. I only have to insert one thing, right? Name. So insert into publisher, name, values, and you still use values, even though you could use value. Just use values to be consistent. Naughty Dog. There we go. First of all, what do you notice at the end of every single line? Semicolon, just like Java, just like C, right? And what do you see? What do you notice about, say, strings? Double quotes. If you want to, you can use single quotes. Just like Python, you can use either or, as long as you're being consistent about it. All right, there we go. And undo. All right, oops, redo. Values, Naughty Dog. There we go. I typically will go with double quotes there, just because it's absolutely clear to me that it's a string. Right? Even in Python, I'll go with double quotes. Right? All right, so insert into publisher, name, values, Naughty Dog. Execute that, and you see down here that there was a green light, green check mark. It worked. If I had a syntax error, for example, Naum, right? That's not a syntax error. It's I've misspelled the column name. Or if I had a syntax error, for example, I put in a space there, right? Well, first of all, it's going to highlight that, but it's going to fail. Red X means that it didn't happen. Right? So it did not insert values, any value, because there's no, in fact, it says unknown column Naum in publisher. Right? Name. Should I do it twice? This is a good question. Should we have 2 publisher records with the same name, Naughty Dog, Naughty Dog? Right? Probably not. Let's first of all make sure that it worked. Let's go over here to publisher, and we see Naughty Dog down there has been assigned a value of 14. Why? Because that was what was next. Right? You can do that manually. You can, but should not, specify primary keys. Right? So for example, I could say insert into publisher, publisher ID, name, and I don't know, 10, Naughty Dog. Is that going to work? Let's come back over here to publisher and look at the data in there. Is that going to work? There's already a publisher with a value of 10. Let's find out what happens when I try to do something like this. X. And I get a different error code message down here. Duplicate entry 10. Right? You can't have two values with the same primary key. The database is taking care of it for me. The database is saving me from myself, right? Because I designed it well and I said that this is a primary key auto increment. You take care of it, database management system. Right? All right, so, well, maybe 20, right? 20 was not being used, right? So we're safe there. Let's go ahead and execute that. There we go. And let's go ahead and look at all the publishers again. We now have two publishers named Naughty Dog, Naughty Dog. One of them with a value of 14 and one of them with a value of 20. Because we specified different primary keys, this is perfectly fine. You can put a uniqueness constraint on a column like name, right? In fact, you can sort and resort these. Let me go ahead and resort. Nope. Okay. I don't know why it's not sorting with respect to that, but whatever. In any case, you can put what are called constraints, saying that there can only be a publisher with this one specific name. I chose not to do that here. Right? And so as a consequence, I've got two Naughty Dogs. Right? Let's fix this by immediately going to the destroy. Right? How do I do that? So let me go ahead and remove the duplicate entry for Naughty Dog. Right. Oh, and by the way, how am I doing? Is this real SQL code right here? Nope. What is that hyphen in front of it? What do you think that is? It's comments. That's how you do comments in SQL. All right. So let's remove the duplicate entry for Naughty Dog. Delete from publisher. There we go. Ooh. Let me try this first. Let me go ahead and actually clear this out. Right-click, clear. And let me go ahead and try doing this. Before I do this and show you the effects, you tell me, should I be able to do this? What am I saying? Delete from publisher. Did I say delete that one record over there or delete those 3 records over there? What did I say? Unqualified, I said delete every single record from the table. It just saved me from myself. Right? You are using safe update mode. Thank God. Right? Safe update mode. You tried to update a table without a where clause, and therefore you would have deleted everything. Right? So bad, but safe mode prevents you from deleting everything in the table. Now it doesn't delete the table itself. Even if this were successful, I'm not deleting the table. The table still exists. I would be deleting every single record from the table. Okay. If you want to delete, delete an entire table, you would actually say drop table publisher, right? And it's not going to let me do that either, hopefully, because I've got a constraint. I have a game table over here that references the publisher table. At this point, let's go ahead and think about this. Can a publisher exist not having published any games yet? Can a game exist without a publisher? Yes to the first one, no to the second. Why? Because a publisher can exist. All they need to exist is a name and an ID. But can a game exist without a publisher? They need an ID, they need a name, but what else do they need? A publisher ID. Without that, they don't exist. Okay? So you can't drop a table, you can't create a record that references another record that's invalid. Right? If you wanted to delete an entire table, you could do something like this, though. Right? And we'll do that later when we actually design tables. All right, so don't do this, right? But do this. Safely delete one record using a where clause. Right? So I want to delete from publisher. Which one did we want to delete? Where publisher ID was equal to, I think I said 20. Right? Green check mark. That worked. You only deleted one record. In fact, it'll tell you one row affected down here. Let's come back up here and look at all the publishers. That extra Naughty Dog is now gone. Right? There's really nothing fancy with respect to both of these. Inserting stuff, destroying stuff, I mean, it's an insert statement, it's a delete statement. Okay? All right. Let's go ahead and insert the actual Last of Us, right? Insert into game, right? Let's see, name, let's say name, values, The Last of Us, or just Last of Us? The Last of Us. Last of Us. There we go. Now, am I going to be able to do that? Oops. Let me jump all the way down here. Sorry. Let me find out. Right, just in case you didn't see it, let me go ahead and clear that out again and execute that again. Right? Red X. Why? Again, what did we just get done saying? Can a game exist without a publisher? Nope. This key right here will be auto-generated for you, and so you don't have to worry about it. But down here, the name, that has to be provided as well, but also the publisher ID has to be provided. Right? Okay, so let me go ahead and add in publisher ID. Right? And, ooh, what was the publisher ID? 14? Okay, so you can hard code a foreign key, or FK, this is foreign key, right? Or you can use a nested loop. Right? So for example, what I'm going to do is, I'm not going to execute that yet. Right? What I'm going to do is I'm going to say, I don't know what that publisher ID is. I don't want to have to hard code that. So what I'll do is I'll go ahead and say, select publisher ID from publisher, where name is equal to Naughty Dog. Naughty Dog. There we go. Right. This is a subquery that will go to the database, look up the game with that particular title, give you the publisher ID, and then instead of hard coding this 14 here, that 14 gets replaced with the 14 pulled from the database. So you can use a nested loop here, or you can just hard code values. When you're doing your database stuff, I would recommend hard coding those values. Why? Because that's exactly what I did over here. Oops, I don't want a new model. Let me go ahead and show you. I didn't show you all the details of the video game database, but let's take a look at it. Right? So what I did is I hard coded all these values. That is perfectly okay for test data, right? Because you want to make sure that I insert this one, I need to relate them together. I need predictability out of my keys. And so I will go ahead and hard code these key values, but that's only okay for test data generally. Right? Let me go ahead and get rid of that. Right? If you're interested in the video game database, it is available on the note sets, or I think in lab 7 as well. Right? You'll have an albums database there, though, instead of a video game database. So let me go ahead and actually execute this. There, green check mark, it works. Let's come back up here and verify that it worked. Let's go ahead and pull out all the video game data, information, and its publisher ID is 14. There's The Last of Us, and it was assigned a brand new value of 21. Again, I could have hard coded that. What is another game that they published? Uncharted. Say what? Uncharted. Uncharted. There we go. And I'll go ahead and say, well, I do want game ID here. And I'll just go ahead and make it large, 100, because I know that that's big enough, right? I looked and it went from 1 to 21 or something. So let's go ahead and execute that. That worked just as well, right? There is this huge gap, however, now in my game ID. Right? If that bothers you, get over it. Right? You're not going to have that much control over primary keys. Right? Yeah, I'm skipping a whole bunch here. What's going to happen is that the database is going to, an integer is a 32-bit integer, unsigned, I think. So it's, once it gets to about 4 billion records, it'll start back over and then use unused keys. If you've got 4 billion records in one table, awesome. You've got a lot of data, right? Then you're at the limit, right? In fact, I think that there's, you're not even going to hit 4 billion records. There's going to be a memory issue with MySQL before you even get there. Yeah, it's nice to have nice contiguous key values, right? All in the row. You're not always going to have that in real life, so just get over that peculiarity, right? Otherwise, I've got Uncharted and The Last of Us already in there. Same publisher ID, because that's what I set it to. Okay? You can insert multiple things at the same time. Values. Is there an Uncharted 2? There is? Okay. Already or in development or what? Already out? Okay. And I'm pretty sure that there's a Last of Us 2, right? The Last of Us 2. I don't know if it's 2 or whatever, but there we go. If you want to insert multiple pieces of data in the same query, you can do that. I'm crossing my fingers here to make sure that this is the correct syntax. And it is. Yay. Let's come back up here and see that those sequels are both in the database now as well. Basically, it just saved me some repeated typing, right? Instead of doing it in 2 queries, I did it in 1 query. All you have to do is, these are tuples, right? If those coming from a Python background will immediately recognize this as a tuple, a triple in this case, or no, sorry, a double in this case, a pair, right? And this is a tuple, comma, tuple, comma, tuple, comma, tuple, right? All right. Any questions so far? Do we have a third game that I can use? Oh, well, did they do that? Oh, they did? Crash. Bandicoot. Caught? What? Oh, okay. Is it like that? Okay. It doesn't really matter because Bandicoot. There we go. I'm actually going to intentionally misspell it because I'm going to show you the other one, update. Right? So let's go ahead and go back up here and look at that bad game that we just put in there. I misspelled it with a K instead of a C. That's okay. Once that data is in there, we can always update it. Update my misspelling. Right? So I'm going to update game, set title, or set name, equal to Crash Bandicoot. Right, there we go. Is that the correct spelling, first of all? Okay. Tell me, what am I going to end up doing here? Setting the title, the name of every single game to Crash Bandicoot, right? Because I don't have that where clause. Again, it will protect me from myself. You are using safe mode update and you tried to update a table without a where clause. You should not be setting the name of every single game in this table or in this database to Crash Bandicoot. So let's go ahead and go back and figure out how to do this with just one record. Generally, you do this with the primary key. The primary key that was generated in this case is 103. So let me go down here and add a where clause, where game ID is equal to 103. There, green light go, and it has been changed. I will note here that if you are using a tool like MySQL Workbench, you can do stuff like this. Foobar, Baz. There we go. Hit enter. And what you can do is you can go ahead and execute this, edit that, insert a new row, delete this. I think it's, is it this one? Export, nope. Import, how do I, this one? Refresh data? No. Reset all sort, nope. Okay, so maybe this? Nope, there are pending changes. How do I execute those changes? Where is it? Query stats. There should be like an, execute, where are you? Anyway, there's a way to do it. If I close this, there we go, apply. All right, and what will it do? What it will do is it will generate SQL code for you that you can then cut and paste and run yourself, or you can just say, okay, yeah, that looks good. I'll go ahead and apply that. Right? I don't want to do that, so I'll go ahead and exit out of that. Right? I will go ahead and close this. Don't apply because I don't actually want to make those changes. The takeaway there is that you can do graphical user interface. You can do changes and updates using a graphical interface like this, or better yet, just start learning SQL and do it all like this. Okay. That took us very quickly through the first three, right? Create, you can put stuff into a database. Update, you can change existing data that already exists in the database. You can remove data from the database. So what we're going to do next time is focus on the retrieval. how do we select stuff out of the database? Because remember, we've got this relational database management system with 4 different tables. How do I take data in that table and bring them together to produce a report? I'm going to have to do joins. I'm going to have to do a lot of clever stuff. And so that's going to take the vast majority of our time. Otherwise, these other 3, create, update, and destroy, they aren't fancy, right? They're just 3 statements. Here, with retrieve, it gets fancy, right? All right, we'll pick it up there next time.